Hi students, my name is 𝗳𝗍𝗃. I would like to teach you all physics. Now today we discuss units and measurements. Now, so in this here, now what is chapter name? Units and measurements. Units and measurements. Units and measurements. Now, so this chapter related to total all chapters. Now, in this, what is unit, what is measurement? Here, unit means what? Standard quantity. What is measurement? Here, measurement means what? Measuring anything means comparing the given physical quantity with the standard. Suppose what is length of the chalk piece? Suppose length of the chalk piece is 5 centimeters. Now 5 is the magnitude, centimeter is the unit. Now here centimeter is the standard quantity. Centimeter is the standard quantity. Now 5 is the magnitude. 5 is the magnitude. Here what is magnitude? Number. Number of times are the standard quantity present in the given quantity. Now here, so from this what we understand? Here every measurement consists of two parts. One is the magnitude, other one is the unit. Every measurement consists of two parts. One is the magnitude, other one is the unit. Now in this chapter we discuss total relation between units, relation between unit and numerical value, and also system of units, errors, everything we discuss, and also dimension analysis, dimension formulas. Now here, so basically here most of the physical quantities we come across in physics are mainly divided into two groups. What are that? Fundamental quantities. First of all, we have fundamental quantities. Second one, derived quantities. Now, fundamental quantities means what? Physical quantities which are independent of other. Physical quantities which are independent of other. Example, length, mass, time. Length, mass, time. Derived quantities. Derived quantities means what? Physical quantities which can be derived from fundamental quantities. Now suppose area. Area is equal to what? Length into breadth. Area depends on length and breadth. So area is derived quantity. Now speed. Speed is equal to what? Distance by time. Speed is derived quantity. Now density. Density is equal to what? Mass by volume. Derived quantity. Like that. Physical quantities which are independent of other quantities. Independent of other quantities are called what? Fundamental quantities. Example, length, mass, time. Otherwise, physical quantities which can be derived from fundamental quantities, that are called what? Derived quantities. Example, area, speed, density, force, like that. Now here again units. Unit means what? Standard quantity. These units also divided into what? Two groups. So first of all, what I told, physical quantity. What is physical quantity? All measurable quantities. Physical quantity means what? All measurable quantities are called what? Physical quantities. Now these physical quantities are two types, fundamental units and derived units. After that, again units. Units also divided into two parts. What is unit? Unit means what? Standard quantity. To measure any physical quantity, a standard of same quantity is essential. Now the standard quantity is called what? Unit. Now here, these units also divided into two groups. What are that? Fundamental units and derived units. Now meter is used to measure length, but meter square is used to measure what? Area. What is the area? Length into breadth. What is unit of length? Meter. What is unit of breadth? Meter. So meter is fundamental unit, but meter square is derived unit. Meter square is derived unit. Volume. Volume is equal to what? 𝗹𝗶H. Volume is equal to 𝗹𝗶H. What is unit of volume? Meter cube. Now meter cube is used to measure what? Volume. And meter per second. What is speed? Speed is equal to what? Distance by time. What is unit of length? Distance, meter. Meter per second. Meter is fundamental unit. Meter is fundamental unit, and meter per second is the derived unit. Meter per second is the derived unit, like that. So anyhow, unit means what? Standard quantity. What is standard quantity? To measure any physical quantity, a standard of same quantity is essential. That standard quantity is called what? Unit. Now unit value lies in the international agreement. Unit value lies in international agreement. Now, and also we discuss system of units. Here, we have system of units. Here, now system of units. System of units. System of units. To measure fundamental quantities, length, mass, time. Three different systems were developed. Before 1960, to measure fundamental quantities, length, mass, time, three different systems were developed. What are that? CGS, MKS, FPS. CGS, MKS, FPS. Now, here C stands for what? Centimeter. G stands for what? Gram. S stands for what? Second. And MKS, meter, kilogram, second. And FPS, foot pound second. Foot pound second. Like that. Now, these three different systems before 1960 to measure fundamental quantities, length, mass, time, mainly three systems are developed. What are that? CGS, MKS, FPS. So, in CGS means what? C stands for what? Centimeter, gram, second. These are used to measure what? Length, mass, time. MKS, meter, kilogram, second. FPS, foot pound second. Foot pound second are used to measure what? Length, mass, time. So, how they are asking question? Which physical quantity having same units in? Which physical quantity having same units in all systems? Which physical quantity? Time. In case of time, what is the unit of time in all systems? Second only. So, how they are asking question? Which physical quantity having same units in all systems? Even SI system also second only, like that. Now, after that, mainly we have three systems. In 1960, International Bureau Association of Weights and Measurements approved a new system, that is SI system. Here, before 1960 we have only three systems. After that, we have in 1960 International Bureau Association of Weights and Measurements approved a new system, that is SI system. SI represents what? System of International. System of International. Now this SI system consists of 7 fundamental quantities and 2 supplementary quantities. 7 fundamental quantities and 2 supplementary quantities. What are 7 fundamental quantities? Already here we have 3 fundamental quantities. What are that? Length, mass, time. Again 4 fundamental quantities are added. What are that? Thermodynamic temperature. Thermodynamic temperature. And 5th one, quantity of matter. 6th one, luminous intensity. Next one, strength of electric current. Strength of electric current. Here, what is unit of length? Meter only. Here, SI system is the extension of MK system. SI system is extension of MK system. Unit of length is meter. Unit of mass is kilogram. Unit of time is second. And thermodynamic temperature, Kelvin. And quantity of matter, mole. Luminous intensity, candela. And strength of electric current, ampere. Strength of electric current is ampere, like that. Here SI system is extension of MK system. Now SI system consists of 7 fundamental quantities and 2 supplementary quantities. Now 7 fundamental quantities, what are that? Length, mass, time, thermodynamic temperature, and quantity of matter, luminous intensity, and strength of electric current. After that, again we have 2 supplementary quantities. What are 2 supplementary quantities? Here plane angle, solid angle. Plane angle and solid angle. Now, what is unit of plane angle? Plane angle, unit of plane angle is radian. Solid angle is steradian. Like this. Now, this chapter is very, very important in physics. Now, this chapter total measurements. So, anyhow, these units are very, very important. And also, here in SI system, here unit means what? What I told? Standard quantity. To measure any physical quantity, a standard of same quantity is essential. That standard quantity is called unit. Now this meter, kilogram, second, everything having standard definition. It is standard quantity, like that. Next one, here SI system. Here in this we have rules and regulations in SI system. Once you read rules and regulations also. And also here what are the rules and regulations in SI system? Here symbols for units do not take plural form. And also suppose current flowing through the wire 2 ampere but not 2 amperes. 2 amperes. And also here while writing full names of units named after a scientist, capital letters should not be used. While writing full names of units, unit of electric current, ampere. So, ampere is scientist name. So, we write ampere but not ampere. Here, what is this? Full names of, here while writing full names of units named after a scientist, ampere is scientist name. Ampere is scientist name. So, we write small letters but not ampere. Here, unit of force, Newton but not Newton, like this. Here, if it is scientist name, so we write small letters, that is second one. And also, here while writing symbols of units, named after a scientist, capital letter should be used. A for ampere, J for joule, A for ampere, J for joule, and W for watt, like that. And also, here in case of other symbols, capital letters should not be used. M for meter, kg for kilogram, S for second. And also, next one, here no full stops or any other punctuation mark should be used within or at the end of the units. Suppose force acting on a body, 5 Newton, that's all. No full stops or any other punctuation mark. No full stops or any other punctuation mark should be used within or at the end of the units. And also, some gap should be leave between numerical and symbol of unit. Now, here numerical and symbol of unit. Here we are leaving some gap between numerical and symbol of unit, and also between the symbols of compound units. Momentum of a body. Momentum of a body how much? 20 kg meter per second. 20 kg meter per second. So, like this. We are leaving some small gap. Small gap should be leave between numerical and symbol of unit, and also between the symbols of compound units. And also between what? Symbols of compound units. And this slash should not be used. Suppose here unit of current, unit of speed. Speed how much? Meter per second. Now according to SI system, this slash should not be used. So we write like this, meter second inverse. Meter second inverse. These are the rules and regulations in SI system. Is it clear? First one, what is that? Symbols for units do not take plural form. 2 ampere but not 2 amperes. Force acting on a body, 5 Newton but not 5 newtons. Here, and also current flowing through the wire. What I written here? Example, 2 ampere but not 2 amperes. And full names of units. Here, while writing full names of units named after a scientist, capital letters should not be used. Capital letters should not be used. So, unit of electric current is ampere. So, we write small letters but not ampere. And Newton, unit of force is Newton. So, we write Newton but not Newton, like that. And also, symbols for units. Here, while writing symbols of units, named after a scientist, capital letters should be used. A for ampere, J for joule, W for watt, like that. In case of other symbols, capital letters should not be used. M for meter, kg for kilogram, S for second, like that. And also, some gap should be leave between numerical and symbol of unit, and also between the symbols of compound units. And also next one, here no full stops or any other punctuation marks. No full stops or any other punctuation mark should be used within or at the end of the units. Don't write full stops, like that. These are the rules and regulations in SI system. And also in this, we discuss relation between unit and numerical value. Now, here already explained, every measurement consists of what? 2 parts. Suppose mass of a body 2 kg, mass of a body 2 kg in SI system. Now same thing can also be expressed as 2000 grams. 2000 grams. Now first of all, 2 is the numerical value, kg is the unit. Where mass of a body 2 kg in SI system. Same thing can also be expressed as 2000 grams in CGS system. 2000 is the numerical value, gram is the unit. From this what we understand, less is the numerical value, more is the unit. More is the numerical value, less is the unit, like that. So from this, N1U1 is equal to what we write? N2U2. What are N1 and 2? N1 and 2 are numerical values. U1, U2 are corresponding units of a given physical quantity. Here, N1 and 2 are numerical values. N1 and 2 are numerical values. U1, U2 are corresponding units of a given physical quantity. Then we can say N1, U1 is equal to how much? N2, U2. Here from this 2 kg is equal to what? 2000 grams. Is it clear? Now N1 and 2 are numerical values, U1, U2 are corresponding units of a given physical quantity. What we can say? Then we can say N1 U1 is equal to N2 U2. So measurement always constant, Nu is constant. Here numerical value is equal to what? C by U. Numerical value is inversely proportional to unit. Unit is less, numerical value is more. Unit is more, unit is less, numerical value is more. Unit is more, numerical value is less. You understand this example? Here 2 is the numerical value, kg is the unit. Unit is more, numerical value is less. 2000 grams, gram is unit, gram is unit, it is less, numerical value is more. Less is the numerical value, less is the numerical value, more is the unit. More is the numerical value, less is the unit, like that. So what is the relation between unit and numerical value? Inversely proportional to each other, n proportional to 1 by u, n proportional to 1 by u, like that. And also, now depends on this, we have problems also. Nu is equal to constant. Numerical value, every measurement, what we understand here, every measurement consists of two parts. One is the unit, other one is the numerical value. So what is relation between? Relation between unit and numerical value? Numerical value is inversely proportional to unit. Numerical value is inversely proportional to unit, like that. And next one, now we have dimensional formula. Dimensional formula. Now what is dimension formula? Q is equal to m power a, L power b, T power c. Now Q is one physical quantity, like this. Q or x, some x is one physical quantity. Now x is equal to what we write? M power a, L power b, T power c. Now what is dimension formula? It is an expression which represents a physical quantity in terms of fundamental quantities. Here dimension formula, how we write here? Dimension formula always in terms of fundamental quantities. Now here, what is dimension formula? It is an expression, it is an expression which represents a physical quantity in terms of fundamental quantities. Now what are ABC? ABC are the dimensions of mass, length, time. Mass, length, time. What are dimensions? Here dimensions are the powers only. Dimensions are the powers to which the fundamental quantities are raised to obtain the dimension formula of a given physical quantity. What is dimension formula? Dimension formula, it is an expression. It is an expression which represents a physical quantity in terms of fundamental quantities. In terms of fundamental quantities. ఇక్కడ భౌతిక రాశి అనేది ఈ దానికి మితి ఫార్ములా ఉంటుంది. ఆ మితి ఫార్ములాలో ఇక్కడ m పవర్ a, L పవర్ b, T పవర్ c, ఏబీసీలను ఏమంటాం మనం? ఏ ఈజ్ ద డైమెన్షన్ ఆఫ్ మాస్, అంటే ఏ అనేది మాస్ యొక్క మితి. ఇది మొత్తాన్ని ఏమంటాం మనం? మితి ఫార్ములా అంటాం. అయితే ఇక్కడ డైమెన్షన్స్, వాట్ ఈస్ డైమెన్షన్ ఫార్ములా? ఇట్ ఈస్ అన్ ఎక్స్ప్రెషన్ which represents a physical quantity in terms of fundamental quantities. What are dimensions? Dimensions are the powers to which the fundamental quantities are raised. For what? To obtain the dimension formula of a given physical quantity. Now suppose dimension formula for length. Dimension formula for length, L. Length, breadth, height, distance, displacement. Distance is nothing but what? Here, length of actual path travelled by the body. So dimension formula for distance how much? L. So what we write now? L, m power 0, L, T power 0. It is independent of mass and time. So what we write now? L. Dimension of length how much? 1. Area is equal to what? Length into breadth. Area is equal to length into breadth. What is dimension formula for length? L, breadth L. What we are getting now? L square. Here we have L, here what we are getting? L square. What we write now? M power 0, L square, T power 0, like that. Here, so what are dimensions? Dimensions are the powers. In case of volume how much? LBH, so L cube. Here we have L cube. In case of length, dimension of length how much? 1. In case of area, 2. In case of volume, 3, like that. Here dimensions are the powers. Dimensions are the powers to which the fundamental quantities are raised to obtain the dimension formula of a given physical quantity, like that. Now, here we discuss dimension formulas of different physical quantities. So in examination, how they are asking? Here, which physical quantity having negative dimensions in mass? They are giving options: universal gravitational constant, universal gas constant, Planck's constant, like that. What is question? Which physical quantity having negative dimensions in mass? So that's why better thing. So we learn all dimension formulas. If we are learning dimension formulas, how we learn? First we write formula. Here, if you want to write dimension formula, so if we know formula, మనకు ఫార్ములా తెలిస్తేనే మనం డైమెన్షన్ ఫార్ములా రాస్తాం. అయితే ఇక్కడ if once you learn all dimension formulas, simply you are getting more than 10 to 20 questions. Easily you can do. Here in intermediate physics, total we have nearly 80 to 90 physical quantities are there. So here whatever may be the exam. So if you are learning dimension formula, simply you are getting. If you are learning dimension formulas means what? You know the formulas. So in any paper they are giving direct questions also. So that's why dimension formulas are very, very important, whatever may be the exam. Now first of all, here already I told that length, breadth, height, wavelength, radius. What is that? Length, L. Length, breadth, height, wavelength, distance, displacement, radius, diameter, like that, L. Next one, area. Area how much? Length into breadth, we are getting L square. Volume. Volume how much? 𝗹𝗶H. So L cube, like this. So what are dimensions of mass here? L means what? M power 0, L, T power 0. M, here M power 0, L, T power 0, like that. Here M power 0, L square, T power 0. L cube, M power 0, L cube, T power 0, like that. Next one, speed. Speed is equal to what? Distance by time. Speed is equal to distance by time. Distance, L, time is T. How much you are getting? L T power minus 1. Speed. Speed or velocity. What is the formula? L T power minus 1. Acceleration. Acceleration is equal to what? Change in velocity by time. Change in velocity how much? Change in velocity is nothing but velocity. So L T power minus 1 by T. How much you are getting? L T power minus 2. Next one, force. Force is equal to what? Mass into acceleration. Mass, M. Acceleration, L T power minus 2. Force, tension, thrust, weight. What is weight? Gravitation force acting on a body. So acceleration and also acceleration due to gravity. What is acceleration due to gravity? Acceleration of a freely falling body due to gravitation force of attraction. So acceleration and acceleration due to gravity having same dimension formula, L T power minus 2. Force, thrust, here force, thrust, tension, weight, whatever it may be, dimension formula how much? Mass into acceleration. What is dimension formula for mass? M. Acceleration how much? L T power minus 2, like that. Next one, work done. Work done is equal to what? Force into displacement. Force into displacement. Force how much? ml T power minus 2. Displacement how much? L. What we are getting now? ml square T power minus 2. ml square T power minus 2. Work done. Work done and energy. What is energy? Capacity to do work. Energy means what? Capacity to do work. Here there is no separate formulas for energy. So work and energy are having same units and dimension formula. Energy, kinetic energy, potential energy, heat energy. So dimension formula what is that? ml square T power minus 2. Torque. Torque is equal to what? Force into perpendicular distance. So dimension formula of torque also same thing. ml square T power minus 2. And next one, power. Power is equal to what? Work by time. Work how much? ml square T power minus 2 by time. What we are getting now? ml square T power minus 3. ml square T power minus 3. This is dimension formula for power. Like that you learn all dimension formulas. And next we have here angular velocity. Angular velocity means what? Angular displacement theta. For angles no dimension formulas. Now angular velocity. Angular velocity is equal to what? Angular displacement by time. Angular displacement for angles no dimension formula. So what is dimension formula? T power minus 1. T power minus 1, like that. Here dimension formula of time how much? T. Now what is dimension formula for angular velocity? T power minus 1. Angular acceleration. Angular acceleration how much? Rate of change of angular displacement. So T power minus 1 d omega by dt. How much? T power minus 1 by T power minus 1. T. So what we are getting now? T power minus 2. T power minus 2. This is the dimension formula for angular acceleration. And also, so like that you learn all dimension formulas. So now, next we have, what is dimension formula for torque? Torque how much? ml square T power minus 2 only. Next we have moment of inertia. Here moment of inertia means what? mk square. Moment of inertia, mr square or mk square. What is k? Radius of gyration. Moment of inertia, I is equal to mk square. Now mass, dimension formula for mass is m. K is nothing but distance, so ml square. This is dimension formula for moment of inertia. And momentum is what? Product of mass and velocity. Mass m, velocity lt power minus 1. Momentum or impulse. Impulse means what? Change in momentum of a body. So what is the dimension formula? mlt power minus 1. mlt power minus 1. And also, next one, time period. Time period means what? Time period is nothing but time. So dimension formula for time period is t only. And next one, we have angular momentum. Angular momentum. Angular momentum is what? L bar is equal to what? R bar cross P bar. R bar cross P bar. So L bar is equal to what? What is R bar? Distance. L, momentum, mass into velocity. Velocity means what? lt power minus 1. We are getting ml square T power minus 1. What is L bar? Angular momentum. Dimension formula for angular momentum how much? R into P. R means what? Distance. Momentum. Momentum is what? What is angular momentum? Momentum of a particle. Momentum of a particle is called what? Angular momentum. So dimension formula how much? ml square T power minus 1. ml square T power minus 1. Here sometimes in examination they are asking which physical quantity having same dimensions. Which physical quantity having same dimensions. What I told? Speed, velocity, acceleration due to gravity, torque and work, torque and work. What is the dimension formula for torque? ml square T power minus 2. Work, ml square T power minus 2. So you must thorough in dimension formulas. How it is possible? First you learn all dimension formulas. So directly they are asking which physical quantity has negative dimensions in mass. Here one more thing, universal gravitational constant. How? What is gravitation force? F is equal to what? G m1 m2 by r square. Like this. What is force here? Gravitation force. Whatever may be the force, dimension formula is same. What is dimension formula for force? mlt power minus 2. Now from this, G is equal to fr square by m1 m2. What is dimension formula for force? Mass into acceleration. mlt power minus 2 r square L square by mass m into m. Like this. Mass gets cancelled. We are getting m minus 1 L cube T power minus 2. How they are asking question? Which physical quantity having negative dimensions in mass? Which physical quantity here? Universal gravitational constant. They are giving options. What are that? Universal gas constant, Planck's constant. None of these. What is the answer now? Universal gravitational constant. What is the dimension formula? m minus 1 L cube T power minus 2. So if you learn dimension formula, simply you are getting answer. You learn dimension formulas from starting onwards. Otherwise, here we don't know dimension formula for force. How you remember this? So not possible. That's why you learn dimension formulas from starting onwards. And next one, frequency. What is dimension formula for frequency? Reciprocal of time period. Dimension formula for frequency. What is formula for frequency? Frequency means what? Number of oscillations. Frequency F or N 1 by T. What is T? Time period. What is dimension formula for time period? T. Dimension formula for time period is also T. So T power minus 1. So dimension formula for frequency how much? T power minus 1. Like that. Next one. A force constant. Force constant or spring constant. F is equal to Kx. F is equal to minus Kx. Restoring force. K means what? Spring constant or force constant. K is equal to what? F by X. Now, what is F here? Restoring force. Whatever may be the force, dimension formula is same. What is restoring force? Force which brings a body to original position. Now what is Dimension formula for force? Mass into acceleration, m(L)(T)⁻². Distance, elongation, L. What we are getting now? m(L)(T)⁻². m(L)(T)⁻². And also we have surface tension. Surface tension is equal to what? Force by length. What is surface tension? Property of a liquid. Surface tension is the property of a liquid. Here, what is formula for surface tension? Force acting per unit length of an imaginary line drawn on the free surface of a liquid. Now, anyhow, what is formula for surface tension? F/L. What is the formula for force? Mass into acceleration, m(L)(T)⁻²/L. So, what we are getting now? m(L)(T)⁻². A force constant and surface tension. Force constant and surface tension having dimension formulas m(T)⁻². m(T)⁻², like that. Next one we have pressure. Pressure means what? Normal force acting per unit area. Pressure means what? Normal force acting per unit area. Force, mass into acceleration, m(L)(T)⁻², area, L square. So what we are getting now? Here, m(L)⁻⁻1 T⁻². m(L)⁻1 T⁻². It is the dimension formula for pressure. Now, next one, stress. Stress means what? Stress is equal to force by area. Restoring force acting per unit area. Restoring force acting per unit area is called what? Stress. Now, same. Stress is nothing but what? What is formula? Dimension formula for what is formula for pressure? Force by area. So stress and pressure are having same units and dimension formula. And also we have different types of stresses: longitudinal stress, bulk stress, tangential stress, whatever it may be. For unit and dimension formula is same. And also we have strain. What is strain? Change in dimension per unit dimension. Strain. Strain is equal to what? E/L. Here, longitudinal strain, E/L. What is E? Elongation. What is L? Length. Now, change in dimension per unit dimension. Change in dimension per unit dimension is called what? Strain. Now, longitudinal strain. What is longitudinal strain? Change in length by original length. Change in length by original length. Now, what is the dimension formula for change in length? Change in length is nothing but length. L/L. L/L. So, LL gets cancelled. What is dimension formula? m(L)(T)⁻². So, it is dimensionless. Strain is dimensionless. Again, here you know that elastic constant. What is elastic constant? Stress is directly proportional to strain. E is equal to how much? Stress by strain. Stress by strain. That is elastic constant. Now, here we have basically three different types of elastic constants. What are that? Young's modulus, bulk modulus, rigidity modulus. Now, Young's modulus. Is it clear? What is dimension formula for pressure? m(L)(1 T⁻². Stress, force by area. Now, so stress and pressure having same units and dimension formula. Next we have elastic constant. Elastic constant means what? Stress by strain. Within the elastic limit, ratio of stress to strain is called what? Elastic limit. Now, strain having no dimension formula. That's why elastic constant, stress and pressure having same units and dimension formula. What are elastic constants? Young's modulus, bulk modulus, rigidity modulus. Young's modulus, bulk modulus, rigidity modulus. What is Young's modulus? Ratio of, within the elastic limit, ratio of longitudinal stress to longitudinal strain. So, dimension formula for stress how much? Longitudinal stress, m(L)(1 T⁻². Same, force by area. Now, longitudinal strain, no dimension formula. So, anyhow, all elastic constants, either bulk modulus, rigidity modulus, whatever it may be, here, bulk stress, whatever it may be, same dimension formula. Pressure, stress, and elastic constants. Elastic constants means what? Young's modulus, bulk modulus, rigidity modulus, whatever it may be, dimension formula is same, like that. Next one, Poisson's ratio. What is Poisson's ratio? Ratio of lateral contraction strain to the longitudinal elongation strain. It is also ratio of similar quantities. So, it has also no, what is Poisson's ratio? The ratio of lateral contraction strain to the longitudinal elongation strain. So, it is also dimensionless quantity. And next one, here actually we have applications of dimension analysis. Here if we want to study the application of dimension analysis, first of all we must thorough in dimension formulas. Sometimes in entrance examinations they are giving problems on these applications of dimension analysis also. So anyhow, first of all, you must thorough all dimension formulas. And next one, here we have coefficient of linear expansion. What is coefficient of linear expansion? Alpha is equal to what? Increase in length by original length into temperature difference. Increase in length is nothing but length only. Length gets cancelled. What is dimension formula for temperature? K power minus 1. K power minus 1. Kr theta power minus 1. This is dimension formula for linear. What is this? Coefficient of linear expansion. Coefficient of linear expansion or coefficient of areal expansion or volume expansion. Same units and dimension formula. And also, you know, heat energy. Heat already I explained. Heat means what? It is nothing but form of energy. What is dimension formula for heat energy? ml square T power minus 2 only. And next one, here. So like that you learn all dimension formulas. Here, next one, in second year, we have again intensity of electric field. What is intensity of electric field? E is equal to F by Q. What is intensity of electric field? Force acting per unit length of an imaginary line. Here we have electric field. Here the space or region around a charge in which its influence can be felt is called electric field. Now in this electric field, at each and every point we have field and potential. Now what is the intensity of electric field? Force experienced by unit positive charge. Force experienced by unit positive charge. Now what is formula for intensity of electric field? F by Q. F by Q. Already you know dimension formula for force. What is dimension formula for force? ml T power minus 2. Charge, current into time. What is dimension formula for current? A, time T. So what we are getting now? ml T power minus 3, A power minus 1. Like that. What is Q here? Q is charge. What is current? I is equal to Q by T. I is equal to what? Q by T. Now what is I? Current. Current is the fundamental quantity. Q is equal to what? IT. What is dimension formula for current? A, time T, AT. Like that. So dimension formula for charge is AT. So what we are getting now? Intensity of electric field. What is dimension formula? ml T power minus 3, A power minus 1. And also in the field, at each and every point we have potential. Now potential, V is equal to how much? W by Q. V is equal to W by Q. What is that? What is potential? Work done in bringing unit positive charge from infinity to the point. That is potential, you know that. Now V, W, work done. Work done means what? Force into displacement. So how much? ml square T power minus 2. Charge, A into T. So what we are getting now? ml square T power minus 3, A power minus 1. Like that. This is potential. Potential or potential difference also same thing. Potential difference is nothing but what? Potential only. What is dimension formula? ml square T power minus 3, A power minus 1. Like that. So anyhow, you learn all dimension formulas. And refractive index, sin I by sin R, or ratio of velocities. So no dimension formula for refractive index. Flanks constant. What is flanks constant? E is equal to what? H nu. What is E? Energy. Energy means what? ml square T power minus 2. Frequency, T power minus 1. What we are getting now? T power minus 1, T power minus 1 gets cancelled. Flanks constant, ml square T power minus 1. ml square T power minus 1. This is flanks dimension formula for flanks constant. Like that. So anyhow, you learn all dimension formulas. It is useful for solving problems. It is this chapter related to total physics. So if you are learning dimension formulas, you are getting idea about physical quantity, formula and unit. So better thing you learn all dimension formulas. And next one, now we discuss applications of dimension analysis. Applications of dimension analysis. First one, to convert one system of units into another system. To convert one system of units into another system. Second one, to check the correctness of equation. This is conversion. To convert one system of units into another system. That is first use. Second one, to check the correctness of equation. To check the correctness of equation connecting physical quantities. Third one, to derive the relationship between physical quantities. We have three uses. Here I explain one example. So it depends, like that only we are getting problems. Here what are uses of dimension analysis? Conversion. Conversion means what? To convert one system of units into another system. We have different systems. Now here we convert one system of units into another system, and second one to check the correctness of equation connecting physical quantities, and next one to derive the relationship between physical quantities. Now how here, and also before using this we have one more thing. Here we have principle of homogeneity. Principle of homogeneity. What is that principle of homogeneity? Here now we are using, while studying applications of dimension analysis, we are using principle of homogeneity also. What is that? Physical quantities having same dimensions. Physical quantities having same dimensions can only be added or subtracted or equated like this. Here physical quantities having same dimensions. Suppose y is equal to a plus b. So dimension formula for y is equal to what? Dimension formula of a and dimension formula of b, like that. Y is equal to a minus b. So dimension formula of y is equal to what? Dimension formula of a and also dimension formula of b, like that. Here physical quantities having same dimensions can only be added or subtracted or equated. That only, what is that? Principle of homogeneity. Principle of homogeneity. Now we discuss. Is it clear? Y is equal to a plus b. Y is equal to a plus b means what? Dimension formula of y is equal to dimension formula of a is equal to what? Dimension formula of b, like that. And also, what is that? Dimension formula of y is equal to what? Dimension formula of a is equal to what? Dimension formula of b, like that. So I explain one problem now. Displacement of a particle related with the distance, like this they are giving ax plus bx square plus cx, ax square plus bx plus c. Find the dimensions of a, b, c. Like that we have question. Ax square are, we take at plus bt square plus c. Suppose here displacement of a particle related with the time, what is that? Y is equal to at square plus bt square plus c. Find the dimensions of a, b, c. What is this? First of all, according to principle of homogeneity, y is equal to at. Dimension formula of y is equal to what? Dimension formula of at, and also dimension formula of y is equal to what? Dimension formula of bt square. Y is equal to c, like that. Now what is dimension formula of y? Displacement L, a time t. So dimension formula of a how much? L by t. How much you are getting? L t power minus 1. And dimension formula of b is equal to what? Y by t square. Dimension formula of y, displacement t square. How much? L t power minus 2. C is nothing but what? Y. So dimension formula for y displacement, like this. So in this way you are getting question. According to principle of homogeneity, what is that? Physical quantities having same dimensions can only be added or subtracted or equated. Added or subtracted or equated. Y is equal to at. Now what is question now? Displacement of a particle varies with the time. Y is equal to what? At plus bt square plus c. Find the dimensions of a, b, c. How we calculate? According to principle of homogeneity, here dimension formula of y is equal to what? Dimension formula of at. So what is dimension formula? Displacement L. Dimension formula of a we want to calculate time t. So dimension formula of a how much? L t power minus 1. And dimension formula of b how much? Y by t square L t power minus 2. Dimension formula for c L, like that. And also here in this chapter we have, first we have what is that? Still we have applications of dimension analysis, and also we have errors. Now first I explain applications of dimensional analysis. Now first of all, what is that? To check the correctness of equation connecting physical quantities. First one, what is that? To convert. Second one, to check. Third one, to derive the relationship between physical quantities. First one, what is that? To convert one system of units into another. Second one, what is that? To check the correctness of equation connecting physical quantities. Third one, what is that? To derive the relationship between physical quantities. So I explain one example now. Here, suppose everything I explain, first we discuss one thing. To check the correctness of equation connecting physical quantities. Suppose S is equal to ut plus half at square is dimensionally correct or not. They are giving equation like this. S is equal to ut plus half at square, displacement of a particle in time t seconds. S is equal to ut plus half at square is dimensionally correct or not. Like that they are asking. How? We write dimension formulas. Dimension formula for displacement L. Dimension formula for velocity L t power minus 1. Time t. Here for number no units. Dimension formula for acceleration L t power minus 2. T square, like this. Now t power minus 1, t gets cancelled, t power minus 2, t square gets cancelled. What we are getting now? Like this. So that's why it is dimensionally correct. How we are saying? According to principle of homogeneity. Principle of homogeneity. Physical quantities having same dimensions. Physical quantities having same dimension can only be added or subtracted or equated. That's why here S is equal to ut plus half a square is dimensionally correct. Like that we have a number of problems. And also third one, to derive the relationship between physical quantities. To derive the relationship between physical quantities. So in this, for this, they are giving any, they are giving, how they are giving time period of a simple pendulum depends on length and acceleration due to gravity. Time period of a simple pendulum depends on length and acceleration due to gravity. Derive expression for time period. Derive expression for time period. So in this question, you must know the all physical quantities. Here we want to derive relationship between what? Time period, length and acceleration due to gravity. Sometimes here force depends on what? Prior area. Like that they are giving any values. They are giving any values. That's why how we solve this? How we derive expression here? K is proportionality constant. So what we take now? Time period proportional to, we take like this, ath power of length, bth power of g, like this. Time period depends on ath power of length and bth power of g. Now t is equal to k into L power a, g power b. We write dimension formulas now. What is dimension formula for time period? T only, k. Dimension formula of length, L. Dimension formula for acceleration due to gravity. Acceleration due to gravity how much? Lt power minus 2. Lt power minus 2 whole power b. Now t is equal to, what we are getting now? T is equal to k into L power a, here L power b and t power minus 2b, like this. T is equal to k into L power a plus b into t power minus 2b. T power minus 2b. Now we equate comparing the powers of same physical quantities on both sides. What we are getting now? T power how much here? 1. So L is not there means what? L power 0. So a plus b is equal to 0 and minus 2b is equal to what? 1. B is equal to how much? Minus 1 by 2. A becomes what? A is equal to minus b. Now minus of minus 1 by 2. 1 by 2, like this. We substitute now. Now this is taken as first equation. Substitute T, A, B values in first equation. What we are getting? T is equal to k into L power how much? 1 by 2, b power minus 1 by 2. So T is equal to how much? K into L by g power minus 1 by 2. So L power 1 by 2, g power 1 by 2. So what we are getting now? K into L by g. In this way we derive expression. T is equal to what? K into, here T is equal to how much? K into under root of L by g. So they are giving proportionality constant value. K is 2 pi. So if they are giving 2 pi, it becomes what? 2 pi under root of L by g. Like that. Here they are giving proportionality constant. Sometimes they are asking derive expression for viscous force. They are giving any values, any physical quantities. So you must thorough all dimension formulas. Okay. Next class.